Python 3.13 is out, and yeah, there are some improvements and new features, but you're probably here for the biggest news. True multithreading is supported with the new free threaded mode. But to understand the significance of this advancement, it's worth taking a step back to the hardware level and consider the underlying issue. So this is your computer. It has got a CPU, a central processing unit. That is the central hardware component of a computer responsible for executing calculations and instructions. Modern CPUs have multiple cores, allowing them to handle several tasks simultaneously. However, this potential for parallel processing remained largely unused in Python for a long time due to the so-called global interpreter lock, or in short GIL. The GIL exists mainly because CPython's memory management, specifically the reference counting for the garbage collection, which is not thread safe. Without the GIL, multiple threads could modify the reference count at the same time, leading to crashes or corrupted memory. This means that true multithreading, especially for CPU-intensive tasks, was hardly possible in Python until now. Python 3.13 finally overcomes this obstacle and enables more efficient use of CPU cores, which significantly improves the performance in multithreading scenarios. In this video, I'm going to show you how to install Python 3.13, how to enable the free threaded mode, and when to use it, and even more importantly, when not to use it. To download Python 3.13, please go to python.org, then hover over Downloads and then select your operating system. I'm on Windows, so I just click here. On the left, you can see the stable releases. Currently, as I record on the 4th of October, there is no stable 3.13 yet, but on the 7th of October, when you watch this video, you should see a stable Python 3.13 release. So I will use the pre-release version and I will download the 64-bit installer. So I click here. After downloading it, just click here. This will launch the installation process. And here, now very important, you have to customize the installation. Here you don't have to change anything, but here on the next menu, please select the free threaded binaries. So install that. And after that, we can use the free threaded Python 3.13. Okay, now let's have a look at the installation folder of the new Python version. On Windows, you will find the installation under your username, and then in App Data, Local, Programs, Python, and then Python 3.13. Please navigate there, and there you can see two executables, Python and Python 3.13 T. The normal Python executable does not allow you to disable the GIL. The Python 3.13 T version does allow you to disable the GIL. So if you want to disable the GIL, then you have to set the Python 3.13 T as your Python executable. Okay, now let's have a look at how this looks in code. We've got the simple task function. This task function has got a total value, so a variable of 0. We loop over this range object 10 million times and increment the value of total by 1 in each iteration. And we're gonna see how much time this takes with threading and without threading. So we use the threading module, we create a single thread, so we're gonna use 4 threads in total to execute that code. So if we run it, first we have to make sure that we actually use the correct Python exe. So we copy that path, paste it here, and then we're gonna select python.exe and then gil.py. So it nearly takes the same. Let's try it again. And now we can see that it's even a little bit slower. That's the expected behavior because threading actually introduces some overhead and the GIL prevents true parallel execution. So now let's try this again, but this time we're going to use the free threaded version. So we're going to use the Python 3.13 exe and going to run that again. So now we can see that the seconds reduced from 1.3 to 0.5. Okay, so we now achieved real parallel execution and it boosts the performance quite significant. But what's actually the issue here? So we've got this total variable and we increment it by 1. So I created this GIL error file and here we set this counter to a global variable so we can actually print it at the end of the execution. So in this function, we use that global variable counter. As you can see at the beginning, it's 0. We use the range object and loop over this 1 million times and we increment the counter by 1. We use 4 threads to execute it, so we run this 4 times. So the expected value of this is 4 million. So let's try it like this. And now if we have a look at this, we just run python.exe, so the non-GIL free version, and we can see that the expected value is 4 million and the actual value is 4 million. Now let's use the other executable. So we use Python 3.13t, and this time you can see that we've got a value of 1 million and 277,000. So if you run it again, we can see that the value is even different, but it's never 4 million. So why is that? This error occurs because multiple threads are trying to modify the shared counter variable simultaneously without proper synchronization, and that leads to a so-called race condition. So be very careful when using the non-GIL mode, as race conditions can occur when multiple threads modify shared resources. This can especially be important when you try to write to a database without proper synchronization mechanisms like so-called locks. And I guess these mechanisms will become more important in the future. Okay, so that's it. That was the non-GIL mode. So thank you very much for watching. See you in the next video. Bye bye.